everyone, and thank you so much for being here. So like you see, we have a full house, so we can have fun. But no, the good part is, according to me, you guys are the most interested, so you stayed back, and I have the best crowd, so that's awesome. So, today we're going to look into what's new in Cosmos DB, Cosmos DB API for MongoDB, and what are some of the best practices and what our roadmap looks like. So for most of you who are here, I'm assuming you know what Cosmos DB is. If not, I'll give like a brief overview. So Cosmos DB is Microsoft's NoSQL database. It's the industry's first globally distributed multi-model database service. And some of its key value propositions are turnkey global distribution, elastic scale out of both throughput and storage, and it provides fine nines of availability. If you have single master, and if you have our multi-master capabilities, it's 100% availability. And also we have, because you have global distribution, and any person who built an app which is globally distributed know that consistency levels are a challenge. So instead of being eventual or strong, we have 5 well-defined consistency levels you can choose from, and we also have comprehensive SLAs on latency, which is something unique to Cosmos DB. So we guarantee that if you have a 1 KB document sitting in Cosmos DB, and if your application is running in the same region as your Cosmos DB, we guarantee that your reads and writes will be less than 10 milliseconds. So that is pretty powerful. And I won't go into more details. Usually I spend like 10, 15 minutes on this slide, but we only have 45 minutes, and I would like to show mostly demos today. So the whole idea behind Cosmos DB was to exploit the cloud. It's a cloud-native database, and also the idea was to help developers and meet developers where they are. So we provide a bunch of APIs and data models. So if you're familiar with Mongo, you can use our MongoDB API. If you're familiar with Cassandra, you can use our Cassandra API. Our core API is the SQL API, and we also have Gremlin capabilities. So that's Cosmos DB, but what exactly is MongoDB? So even if you don't know Cosmos DB, you probably know MongoDB. So MongoDB has sort of become synonyms for NoSQL databases. It's a very popular NoSQL database. In fact, it was the first NoSQL database I've used when I was way back in grad school. So they have a huge mind share. And if you ever used MongoDB, you'll realize that the syntax is kind of arbitrary. It's kind of elegant, right? To write greater than, you put a $GT, and I'm like, what is this language? But irrespective, it works because it has a huge developer community. If you're stuck with any command, you have Stack Overflow, you have YouTube, you have insane number of blogs, and you will be able to figure it out. So that is the power of MongoDB. But then it's still a community edition, right? So if you have a business-critical application and there are some certain challenges it cannot solve, for example, global distribution, or if you want to have limitless scale, or if you don't want to manage your partitions. So these are some of the capabilities Cosmos DB provides. So we thought, why not make it the best of both worlds? And we have Cosmos DB API for MongoDB. So basically, the way it works is we have an endpoint that's compatible with the MongoDB wire protocol. So if you have applications already running in MongoDB, the idea is that the user or your application developer does not have to spend a lot of time rewriting the application, and they will just be able to change the connection string and point it at Cosmos DB, and the application will still think it's running with still running with MongoDB. And they will be able to take advantage of the huge OSS community MongoDB has and have some of the advantages Cosmos DB provides. So to see this, let's do a quick demo. So actually, this is a pretty fancy demo. Probably would not have set it up for this session, but I was at SQL Pass the other day doing a keynote demo, and I kind of did this, and I'm like, okay, fine, since I set it up, I'm probably going to use it for my session, because it takes a lot of resources. It consumes quite a few Azure resources. So what we have here, and I'm not sure, wait, this is not being displayed. Give me 1 second. There you go. Okay, perfect. So here we have a Tailwind Traders website, which is a globally distributed e-commerce website, and they have customers all around the world. So they want to provide their customers with a low latency, high availability experience. And in this demo, what we did is to power this website and the data inside this e-commerce website, we used Cosmos DB. And here, what I have here is I have two instances of the Tailwind Traders website running next to each other. So the first instance, as you see, is running in the West US and is talking to the Cosmos DB in the West US region. And here, I have another front end running in the East US. So if you see, this is the East US, and this is talking to the East US region. So what I'm going to do here is if I add an item to my cart in the West US region, we can see in action how seamlessly Cosmos DB replicates this data to East US, and it will power the front end in East US. So this is something that is kind of not possible with the MongoDB Community Edition or any other database, this sort of seamless global distribution and multi-master capabilities. So the other thing about the seamless integration, so this is my collection which has the data. So what I'm doing here is I'm going to copy my connection string, and then we're going to look at the data in Studio 3T. So if you guys are familiar with MongoDB, Studio 3T is a very popular Mongo tool to work with your data in MongoDB. So what I'm going to do is I'm going to click New Connection and paste in my URL. And it will connect to my Cosmos DB collections, and it will not even know that it's not talking to MongoDB, but it's in fact talking to Cosmos DB. So you can still work with all of your MongoDB tools, and your applications don't need that much of rewrite. So this was a pretty good win for application developers, and application developers love this, and we have a lot of customers who embrace this. But compatibility is a hard challenge. So, there's a little bit of friction as we were onboarding customers on what their native MongoDB applications, the sort of operators you use, and what they had in terms of the core MongoDB and what Cosmos DB provided. And to make that more frictionless, we've invested the last half year or 1 year sort of investing in how we can make this better. And that's now we have a new release of it called Mongo 3.6, which is supposed to be compatible with our Mongo Server 3.6. So, sorry, just 1 second. So here, with the Mongo 3.6, we address some of these compatibility issues, and it mainly has 3 main pillars. We were aiming at better performance, and when I say better performance, it's mainly reducing the latencies in our request pipelines. Initially, our aggregates were in private preview for the 3.2 and 3.4. Now they're in public preview, and they're super fast. Don't trust me, I will show you the demos. And then we also have improved batch insertion performance. And it also has better compatibility. So before, we had restrictions on cross-collection. So like the data in Cosmos DB will be sharded. So if you have your data across multiple partitions, we had a lot of restrictions in place, like you cannot do cross-partition updates or deletes and so forth. So we have relaxed some of those restrictions to make it more compatible in the way the actual MongoDB works. And also, we've increased a lot of surface area in terms of compatibility in terms of queries, the query operators, and the aggregator operators. We also have now support for compound indexes. That means your sorts with multiple properties. If you have a sort and a find, where the properties in the find is also mentioned in the sort, the performance will be much, much better. And in Cosmos DB, obviously, we have this feature called auto-indexing. So that means all your properties in your JSON document will be indexed by default. But this behavior was sort of new to the MongoDB users, because in MongoDB, they only index the ID by default. And this also was create a bit of surprise. So to increase the more of the compatibility level, we also changed this. So by default, we don't index everything anymore. We index only the ID. And now we also have support for unsharded collections. So previously, we made it a requirement that the users shard their collection and provide a partition key. Now you can go ahead and create unsharded collections under database with a shared throughput, the way you can do in Mongo. And then the biggest feature, which I'm excited about, is change streams. So Cosmos DB did have something called the change feed, but it was only available in our native, the SQL API. Now we have support for change streams also for the Mongo API, and we'll look at all of that in demos. So what I have here is I have a couple of VMs which I already set up because I didn't want to waste too much time in the session itself. So we have, so what we have here is, where is this? Yep. So we have 3 regions here. I have my, I have West US, Southeast Asia, and North Europe set up already, and I have my Cosmos DB accounts in these regions. So what we're going to do is we're going to see how the multi-master capabilities actually work, and what are some of the perf benefits of having multi-master capability. So this is my demo script. This will be available on GitHub later if you want to go ahead and run these demos yourself. So first what I'm going to do is from my VM in North Europe, I'm going to run my insert scripts, which is nothing but it's going to insert some random documents with some properties, like some random properties, like, hey, here's a color, here's an animal, and here are some tags. So this is just a JSON document, which I'm going to generate randomly and insert into the VM. So I'm going to run. So to display the latency, so first I'm already logged into my VM here in the Southeast Asia. So here I'm specifying which region I want to write to. So you in Cosmos DB, if you specify, I'm running the program and I'm specifying through the command line that North Europe is the Cosmos DB region. Sorry, what happened? That was totally supposed to happen. Okay, I just didn't. Okay, there we go. So it's going to take a little bit of time. You're going to see how high the latency is because you're kind of writing from Southeast Asia all the way to North Europe. And hopefully, if the internet is working, that's supposed to, there you go. It's starting to write my documents. And as you can see, the latency is pretty high. It's almost 200 milliseconds, which is no fun, especially when you're working with a globally distributed database. This is not the performance you sort of expect. So let's kill this and run the same thing, but instead, let's point it to the correct region. So here, what I'm going to do is I'm going to run this same script, but now I'm going to point it to my Southeast Asia, where my Cosmos DB is actually running. So we should see that this latency should be typically less than 10 milliseconds. And I see a lot of 7s. So this is sort of the performance benefit you see. And this is something that's not possible in the native MongoDB. So they do have only one primary replica. Multi-master is something that they don't support. And if you have one primary replica, and if you do have a globally distributed customer base, you certainly sometimes have to do this cross-region queries, and they tend to be very expensive. So I'm going to keep this running, and what I'm going to do is I'm also going to run the same thing from my North Europe VM. So we have data being inserted. So we can see in the next step, we're going to see how change feed picks up this incoming changes. Okay, it's going to start up in a second. So yeah, there you go. So we right now we're writing to our Cosmos DB from multiple locations. We have the West Europe demo running, and we also have the Southeast Asia and the North Europe running. So what I'm going to do is I'm going to log into my third VM, which is the West US. And now we're going to run our change feed. So change feed is nothing but it listens to changes for your collection. So every time you insert or update your document, it's written to the change log. And you can do several things. You can use it to do data movement. You can move your data from one Cosmos DB collection to another container. You can move it to blob store. You can do event-driven architectures. There's several things you can do with chain streams. So right now, with our version 3.6, we enabled chain streams. So the syntax here for compatibility, so here, if you look at this part, this is something I want you to pay attention at, because explicitly you have to call out that you have to mention the match in the project clause. This is because right now deletes are not supported in our change feed, and if you don't mention this match and project explicitly, it kind of throws you an error, and you have to like rewrite your syntax. But we chose to explicitly not hide it and not simulate that behavior for compatibility purposes. So we are working on having deletes as part of the change streams, and once that's done, you can exclude and not have to explicitly call them out. But as for now, if you want to set up the change feed, you will have to say you want to say that you want to watch only on match and project. So what I'm going to do here is in my West Europe region, I'm going to okay, let me refresh this very quickly. Yep. And then I'm going to ask it to watch for 1,000 changes. And as we write the documents into Cosmos DB from the North Europe and the Southeast Asia, we should be able to see that the change stream is being triggered. That was pretty fast, but I can run it again, and we'll be seeing that it's going to continuously listen to changes. So here we specified that we want only 1,000 changes, but you could also run the same until exhausted, and it will keep listening for changes, and it will output the data. And also, we have our change feed processing library baked into Azure Functions. So if you want to do something else from there, like say event-driven architectures, that's a good thing. That's a good place to start. So now, yeah. Sorry, can you repeat the question, please?
Sorry, when did you say right before big data?
Big data?
Just a minute ago, you said you have something, blah, 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 big data. You can use it to monitor other changes. Just this.
Oh, so sorry. I was saying that this is baked into Azure Functions, so our change feed processor library to deal with these changes is sort of baked into Azure Functions. So you can set the triggers to listen to these changes, and you can do event-driven architecture. So let's say if you're doing like a shopping cart, and when an order is placed, you can listen for that when the order is inserted into your container. You can have like N other services do other stuff, like hey, generate my taxes, send this order to shipment, say.
How am I triggering that?
So you have Azure Functions. So in Azure Functions, the change feed is already baked in. So you pretty much set a trigger to listen for the changes. So if you go look at, so change feed was already supported in the SQL API. So we have really good documentation on how to set up Azure Functions and then listen for these changes. Cool. So next, let's take a look at the aggregation performances. So we also, aggregation was previously in private preview in 3.2 and 3.4, and in 3.6, it's now GA. So we've been working with our core data science team in measuring latencies and how do we make this API better and where are we lagging. So we've made some very heavy improvements in aggregation. So group by, skip, count, and limit are supposed to be super fast. So I've run some, our data science team has run some experiments before, and they almost saw a 2x or 50% faster improvements from 3.4 to 3.6 for small batch insertions. So here, what we're going to do is we can do a count. So as my documents are being inserted, we can see that this is going to be super fast. And it won't seem like a big deal now. But if you were a user on 3.2 and 3.4, and if you try to do like counts or group bys or sorts, you will see this major difference in performance, especially when for something like a count of, this is about, right now we have about 600,000 documents. For even a batch size of, say, 1 million small documents, this is less than a second or a few milliseconds, which is pretty great, which is a huge improvement from 3.4. So count is great. We also have, you can also do count on a filter. So for example, you can specify, hey, I want to know how many hedgehogs I have in my data. So that's pretty fast as well. And the same thing, we also now support a sort by count, which is an operator which is available in Mongo 3.6. So if we run this multiple times, you will see as the data is being inserted, you will see that it increments pretty fast. So these are kind of like key improvements in terms of performance and the aggregations we've made. And then also we have support for group by or group. So this was in private preview, and now we are GA, and the performance improvements are huge. So here, like you see again, it's super fast, and then we also have, you can also now do unwind. So if I run that, all of these are pretty quick in the 3.6 version. And next, we also have, we also now support compound indexes. So with compound indexes, you have better performance for sort and find when you have multiple properties. So what I'm going to do here is I'm going to, so I already have the index set up, and let's see how these queries perform when we have a compound index in place. So I have a compound index on the properties D and E, and like you see, these are super fast when you have a compound index in here. So yeah, so with we see huge improvement in perf improvements in find and sort, and the last thing is cross-partition queries. So like here, previously we did not support, like say, multiple updates, or if you have documents that span partitions, a cross-partition update or a delete or a counter sort, there were certain limitations on that. So we've relaxed some of those limitations now. So let's go ahead and take a look. So what I'm going to do here is I'm going to create a sharded collection. And then I'm going to insert 1,000 documents into this sharded collection. So we should, okay. So what I want to show you here is basically now we can do updates. We can do updates across partitions, and also we have support for positional updates. So that pretty much means that if you have an array with different things, you can say that, hey, if B is greater than 1, set a flag for A. So these are some stuff that are supported by Mongo, and now it's supported in the Cosmos DB API for MongoDB as well. So I guess the whole idea here is that we are taking a surface compatibility pretty seriously, and we try to want to get to it as, yeah. So there you go. It took a little bit longer than I expected, but yes, it works. Yeah. So mostly what we're trying to achieve is the complete compatibility, and also going forward, we will be focusing a lot on that. So now let's go ahead and also take a look at, so let's take a look at one of the documents, and then I'll go ahead and run the positional update command. So basically here what we have is in this, the 1,000 documents I've just inserted, basically I have an array of a certain set of properties. And what I'm going to do is I'm going to say, hey, if you have, if B is greater than 1, then go ahead and set the flag as 1 where it is greater than 1. So let's see. If I run this, and then if I run the same command again, you should see that the flag should be set. So this is support for, if you see here, we set the flag where B greater than 1. So this is the positional update support. So this is sort of a small subset of demos that I showed today, which came in 3.6. I've also published a blog recently, so if you look for what's new, if you go to our Cosmos DB dev blogs, you have the latest updates there, and you can also check out our 3.6 documentation for the a full list of operators and features which we are compatible with and now support. So that's sort of a gist of what's new. And what I also want to point out is, so when I was setting up, remember the Tailwind Traders demo we just saw with the global distribution? So one fundamental thing I really want to call out here is, yes, now you get the surface compatibility with MongoDB of how your application should work. But the key things I want to keep in mind are, why are you using Cosmos DB API from MongoDB and not just MongoDB? What is that you want to take advantage of? So mostly here, like we already touched on, global replication and multi-master are two key aspects. The other big aspect is scale, like not just scale, but performance at scale. So imagine you're one of these globally distributed applications like Tailwind Traders. Certain days like, say Black Friday, Thanksgiving, or a few days before Christmas. This is when like shoppers start going into panic mode and they do a lot of shopping, and you see extremely heavy traffics. And you should be able to handle those traffics without any downtime. So like even if you're down for like a few minutes, your loss is going to be in some millions of billions of dollars. So these are business critical applications. So what I've done here is we've simulated one such Thanksgiving or Christmas Day sales, and we've been ingesting this data over the past 7 days. So if, okay, I'm already on the 7-day tab. So we see that I have almost a petabyte of data inside of Cosmos DB, like a petabyte. That's a huge amount of data, and which is not very easy for any sort of database to handle. And the other interesting thing I want you to pay attention to is the number of transactions per second. So the average transactions we're seeing is about 95 million. That's close to 100 millions of transactions per second. And that roughly translates to billions of transactions per hour, and even trillions of transactions per day. And this is something you need to be handled seamlessly. And you can, like I was saying, elasticity is another advantage in Cosmos DB. So you can pretty much bump up throughput as and when you need it, instead of having to do a lot of planning ahead. So the other interesting thing I want to point out here is the latency. So we've seen this in action. So pretty much when you have your application running in the same region as your Cosmos DB, we do see very low latencies. So pretty much my reads were, during this entire time, my reads were less than 2 milliseconds, and my writes were between 4 to 6 milliseconds. And this is at the 99th percentile. And we always guarantee that if your document is less than 1 KB, your reads and writes will be less than 10 milliseconds. And we do offer money-back guarantees, SLAs, which no other database pretty much offers on latency. And clearly, we don't want to give your money back, so we will make sure that we do a good job of making sure the SLAs are met. So with that said, what are some of the key problems? This is all great, but what are thinking about it as I work with customers? What are some of the problems I see customers face as they onboard, say, from MongoDB onto Cosmos DB API for MongoDB? So the first thing is understanding throughput. So we have a unique currency called RUs. So RUs are request units, and you sort of, I would say, for you to be successful in Cosmos DB, the three main important things you need to understand are data modeling. You cannot, even though both of them are NoSQL, to get the best performance, you might want to consider data modeling, especially if you have a huge number of collections in Mongo, and if you're trying to migrate an existing collection. Even if you're not, even if you're building a brand new application from scratch, data modeling and partitioning is something you have to absolutely get right to get the best performance in Cosmos DB. And the other thing is RUs. So the biggest challenge I've seen customers figure out is like, hey, I'm ingesting my data, I'm getting throttled. So you see these 429 errors when you're ingesting this data. How do I handle these 429 errors? So we do have, if you go and check our Cosmos DB repo, we do have some samples on how to do the retries and how to handle the 429 errors. But some good news is we also have autoscale or autopilot. We've just announced at Ignite, which is now in gated preview. So when you go to your Azure portal and when you're creating a container, you can select an autopilot container. So that means your Cosmos DB container will automatically provision the throughput as you ingest your data and as your requests increase or decrease for your best pricing performance and even for your application performance. So that's the second thing. And then the third thing is the migration itself. So what are some of the migration tools that are out there and what can you use? So you have the data DMS services, and then you have the Azure Data Factory, and you have a bunch of tools you can use. Also, here today with me, I have Edward from Stream. Stream is one of Cosmos DB's data integrator and data migration services partner. And today we're going to see a very cool demo from Edward on how to do one of these live migrations from MongoDB on-prem onto Cosmos DB API for MongoDB. With that, to you, Edward.
Thanks, Sri. So could I go ahead and go back to the PowerPoint? Really? Awesome. Perfect. So as Sri mentioned, I'm Edward. I'm a solutions architect here at Stream. And so Stream is a streaming ETL platform that allows you to continuously ingest data from a variety of sources and push it to one or many targets. So stepping back a little bit, Stream was founded by the founders of Golden Gate Software, who really pioneered the use of change data capture, or CDC, to read from the logs of transactional databases to turn any production database into a continuous streaming data source. And at Golden Gate, they had a customer advisory board made up of some of the CIOs of the largest customers throughout the world. And there were two main themes that popped out of that. One was, can you support non-transactional sources and targets? So this was around the advent of big data and cloud solutions. Customers really wanted to take advantage of sources and targets that weren't just transactional databases. And then two was, can you do something with my data while it's in flight? Can you introspect, enrich, transform, aggregate, all these various processes that weren't possible with an older CDC technology? So then the team came back together in 2012 to found Stream from the ground up with those two main ideas in play. And so because Stream is a platform, we see customers using Stream for three different use cases. On the left-hand side is cloud adoption. So that's what we'll be showing here. Say you have an on-premise Mongo database. You're really excited about some of the latest updates from Cosmos DB for Mongo API. So you'd like to migrate to Cosmos DB with no downtime. The second being continuous replication. So these are for those business-critical systems that you can't afford to stop, but you still want to take advantage of some of the newer cloud services. And then lastly, you can run SQL queries on your data as it flows through Stream. So this allows you to do some streaming analytics as well. So what we'll be showing today is a zero downtime migration to Cosmos DB. So I have an on-premise Mongo DB, and I want to migrate to Cosmos DB. So within Stream, you can do both the initial load as well as CDC. So let me go ahead and show that to you right now. So how it works is Stream runs in a VM in your environment, and we ship with a web server. So this is where you interact with Stream and create all of your streaming applications. Here we're at the home page. So here you have three different panes. On the left-hand side is the dashboarding pane. So along with moving data in real time, you can also visualize it. This allows you to get some additional context from your data as it flows through your data pipelines. In the middle, we have the applications pane. So what we call applications are your individual data pipelines or data flows. And then lastly, there's source preview, so you can preview your data before moving it. So if we dive into the apps pane, we have two applications loaded up here. So as I mentioned earlier, how an online migration works is you have both the initial load to grab a snapshot of your database at a single point in time, as well as the CDC piece to capture all of those continuous changes as the initial load is propagating to your target. So if we dive into the initial load application, we'll take a look at the Manage Flow page. So this is where you interact with Stream and create all of those applications. So you have all of these out-of-the-box sources in this left-hand menu bar. And the simplest data pipeline is actually what we have right here. Just drag and drop a source, drag and drop a target, configure your various connection properties, and you're good to go. So if we go up here, we have an on-premise Mongo DB that I'm just running on my laptop, which contains an orders table. And in this case, we're writing out to Cosmos DB, so just specifying the various connection properties. So before I continue, I'll just go to my target Cosmos DB instance, show that there's nothing up my sleeve, there isn't any data in this target orders collection. Then we'll go ahead and go back to stream, go ahead and deploy, and then run the application. Looks like it's just taking a minute. This is fun with conference Wi-Fi. Oh, there we go. Well, Murphy's Law, of course we had an issue, but good thing I have a video. So, let's go ahead and start the app to see what it would look like if it was running. So now you can see that data is flowing through stream. As it flows through stream, it looks like a row within a database. So here you can see all those fields from that orders table. And then we also pick up various metadata, which is very helpful in terms of monitoring, making sure that your data actually lands on your target. So let's go ahead and fast forward real quick. A neat feature is this application progress window. So here you have a progress bar, shows your input and output, making sure that your data actually lands on the target. And then if we keep going, we'll go ahead and go to our target, go ahead and refresh that orders collection. And you can see that data's arrived there with all of those various fields. And then if we go back to stream, we also have that CDC application that I mentioned earlier in order to achieve a zero downtime migration. So it looks very similar to our initial load application. The only difference is that within that Mongo DB reader, in the properties, you just select incremental instead of initial load, just in that mode property. And then also writing out to Cosmos DB for Mongo API. So we'll go ahead and deploy and then run that application. And then what I have here is just a few records that I'm going to insert on my source. So this is picking up all those continuous changes, just simulating that that's actually a live database. So now you can see that all the data is flowing through stream, capturing all those various fields, and then propagating out to Cosmos DB. So if we go ahead and go to that employees collection and go ahead and click on any of these fields. And then there's also a monitoring pane, allows you to dive in, make sure everything's running smoothly. So we went ahead and migrated a Mongo DB to Cosmos DB for Mongo API. If you're interested in learning more, please check out stream.com, or you can just deploy Stream through the Azure Marketplace. So back to you, Sri.
Yeah, thank you. That was great. Thanks, Edward. So you have like various options. So you can use if you're comfortable enough, and if you want to do your own data factory and use your own tools, you can do that. Otherwise, you can use something more simple like Stream, where most of the heavy lifting is sort of done for you. So I kind of talked through my slides because I really wanted to get through the demos and not just tell you, oh, we did the aggregate improvements, and I actually wanted to show them. But since we have a little bit of time, I think we have like roughly 5 minutes, I'm just going to do a quick recap, and then I will leave the next few minutes for any questions. So just to sort of go back and see what we went through. So like I said, we now support change feed for, now we support the change streams API. So in the aggregation pipeline, now we have support for group count, skip limit, and we see a lot of significant perf improvements. The other thing we went and looked ahead as was the support for compound indexes. We saw how the queries for sort and find were much faster with the compound indexes. And lastly, we did not see the demo for this, but the key thing I want to mention here is now we do support uncharted collections, which is a very common behavior in MongoDB. So we relaxed that constraint, so you can go ahead and create uncharted collections within Cosmos DB. You can do this both at the shared database throughput level, so you can assign RUs at the database level and create uncharted collections inside Cosmos DB, or you can also have uncharted collections with their own dedicated throughput. So how do you get it? So now if you go to Cosmos DB, and if you create a new Cosmos DB account, pretty much when you select the API, Cosmos DB API from MongoDB, you have the versions, and you can now select 3.6, and you will be able to see all of these features in there, and you can try it yourself. And if you have an existing MongoDB account, like say you're in 3.2 or 3.4, as of now, we're working on make it self-serve, but if you do want to migrate to 3.6, please do create a support ticket, and some of our engineers will help you migrate to the latest version of MongoDB. So what's next? So what are we looking at down in the roadmap, or what will we continue to work on? So at the top of our mind as we do our roadmap planning for the next year, perf improvements is our biggest push. So like I said, we're working with the core data science team, and we are identifying the areas where we can keep improving in. So perf will be on the top of our mind. And the other thing is compatibility. We want to make it as seamless as for you guys and for all the application developers who want to point their applications and take advantage of both Cosmos DB and the MongoDB OSS, the entire OSS community. And the other, to be more specific, some of the features